sigmoidal function. After that sigmoidal function will produce the value between 0 to 1. So this value between 0 to 1 will be considered as the output. In classification, our output is always in the form of class level. So whenever we have output greater than equals to 0.5, that output will be considered as 1. And whenever we have output as less than 0.5, we will consider as it 0. So our final output will be comes according to 0 or 1. So this is the basic concept of logistic regression model. I am telling this because this is the fundamental concept. Now the point comes how to evaluate these models, because this is main problem in the current scenario. So suppose we have developed multiple models of machine learning. We have 10 models, 20 models, 30 models. Then how to identify which model is performing well? So we need to identify based on some quality measures. That quality measures comes under the evaluation technique. In evaluation technique, we will apply certain parameter to all the classification model. Then classification model will produce some value. Based on that value, we can identify that this model is producing good quality or this model is producing bad quality. Okay, so here these are the quality measure or evaluation. So here is a scenario that we are using a classification model. So we have to identify these terminology. I hope all should know these terminology, that there is a forest and there is a fire. So there is a fire in the forest. So if in our testing data set or in reality it is yes, then in reality yes, and our model is also predicting yes, that yes, there is a fire in the forest. This combination is known as true positive. Means in reality it is also fire and our model is also predicting fire. So this terminology is known as true positive. That the result is true, and what is the result? Result is positive. That in both cases there is a fire in reality or in prediction. Similarly, if in reality there is no fire and our model is also predicting no, this condition is known as true negative. This situation is also true because there is no fire in the forest in reality and our model is also saying no. So this terminology is representing true negative. But here, when in reality there is no fire, but our model is predicting yes, that yes, there is a fire. So here the problem is arise. This terminology is known as false positive because in reality there is no fire, but our model is predicting yes. So false is indicating that this decision is false. And what is false? False is positive. That our model is predicting fire in the forest. So false positive. That decision is false and decision is positive because it is saying that there is a fire in the forest. Okay, so false positive. So this condition is considered as wrong decision. And similarly, if there is a fire in the reality and our model is saying no, so this is also a error for the model because in reality there is a fire, but in prediction it says there is no fire. So this terminology is known as false negative. So I hope we have considered or understand all these terminology: true positive, true negative, false positive, false negative. Now we will use this terminology in the confusion matrix. So these terminology will be used in the confusion matrix. Here we can say if in reality yes and in prediction yes, then this is known as true positive. So we will identify all those values for our proposed model. Whenever we will develop a model, we need to identify these values. That in which situation it is, how many number times it will produce true positive, how many number of times it will produce true negative, how many number of times it will produce false positive and false negative. Then we will use, so in this case, true positive and true negative are considered as the correct decision. Because whenever in reality there is a fire, model is also saying that there is a fire. And similarly, when there is no fire, our model is also saying there is no fire. So this is considered as a correct decision. Where is the error? In false positive and false negative. So false positive is considered as type 1 error and false negative is considered as type 2 error. This is depend on the situation or on the application that which type of error is providing more implication on the system. Sometimes false positive has more impact or sometimes false negative has more impact. This is depend on the situation or application to application. So now we have 4 quality measures for our classification model: accuracy, precision, recall, and absence. Now the importance of these quality measures and terminology is we will understand. So here the formula of accuracy is that how many correct decisions our model has given and what are the total number of decisions it is provided. So here true positive plus true negative. This is considered as the correct decision. That how many number of times it will provide true positive and how many number of times it will provide true negative. Divided by total number of cases or total number of decisions. Multiply by 100. This is a formula of accuracy. We will use this formula in every situation of our life. That how many number of times we are correct and what are the total number of times of our decision. So here there is a situation if our model is developed to identify fire in the building. Okay, and 2% chance of fire and 98% time there is no fire. Okay, so in this case we have total 100 decision, but our model is not telling any time that this is a fire. So what will be the accuracy in this case? 98% time there is no fire and then our model is also saying no fire, and 2% time there is a fire, but our model saying there is no fire because our model is always silent. जो भी हम लोगों ने अपना अलार्म सिस्टम डेवलप किया है, that is not working, that is silent. So 98% time it is correct because there is no fire in the building and our model is also silent, means it is also saying that there is no fire. But in 2% cases when there is fire, our model is silent. So it means it is saying that there is no fire. So what will be the accuracy? In this case, the accuracy is 98%. That 98% time our model is predicting correct outcome. Because there is no fire in real and our model is also saying there is no fire. Only 2% time our model is wrong because there is a fire in the building, but model is silent. Model is saying there is no fire. So here we have 98% of accuracy. But if this accuracy is useful, because I have seen in multiple MTech thesis or PhD thesis or research paper that most of the time we are using accuracy parameter for judging a model of classification. We produce that our model is producing 90% accuracy. So we can say that this is a good model. 95% accuracy, then we can say this is a good model. But here it is producing 98% accuracy. So is it useful? No. Because जो हमने सिस्टम डिजाइन किया है फायर के लिए, जो फायर होने पर अलार्म करे, that is not working. जब जरूरत पड़ी then it is not working. So it is almost useless because वो कभी बचता ही नहीं. But वो डिजाइन किसके लिए किया गया था कि जब भी फायर हो then it will alarm. So in reality this system is useless. But in accuracy terms it is producing 98% accuracy. So we should always focus that in which situation the accuracy parameter should be useful for our research. Because many times we are using accuracy or we are saying our model is producing this much of accuracy, so we can say this is a good model. But in reality, that model may not be that much effective. Okay, so we have to observe this kind of situation. The another situation for precision, this is the formula of precision, that true positive divided by true positive plus false positive. So basically, precision is considered always the positive decision, whether it is correct or not. So here we can say the precision that our alarming system should be at least alarm. कि जो भी हम लोगों ने डिजाइन किया है उसकी प्रॉपर्टी होनी चाहिए कि वो अलार्म करना चाहिए. पहले वाले मॉडल की तरह नहीं कि जो कभी भी अलार्म नहीं करता. अब हमने सोचा कि जो मॉडल अलार्म करे उस सिचुएशन पे ज्यादा फोकस है. So we can say precision is a quality measure that true positive divided by true positive plus false positive. So if suppose in another case we are using 20 decision. So 20 times there is a fire in the forest. But our model 10 times says there is fire, but 10 times says there is no fire. So what will be the performance of this model according to precision? Because the formula of precision says true positive divided by true positive plus false positive. So true positive 10 divided by 10 plus what is the value of false positive? False positive value is 0. Because our model is never saying that when there is no fire, or our model is saying there is a fire. FP, the value of FP, false positive is 0. But value of false negative is 10. But false negative is not considering in this situation, in precision situation. So in this situation, the precision provide 100% performance. That true positive divided by true positive plus false positive. The value of false positive is 0. The value of true positive is 10 in denominator and numerator. So precision is saying this model is 100% performing well. But what is the actual situation? In actual situation, it is only performing 50% of it. That अगर 20 times fire हुई और उसने 10 times detect की और 10 times नहीं की, then obviously this is performing only 50% time, but according to precision, it is giving 100% performance because it is not considering the false negative parameter. So here we should focus then when we use to precision, when we use to recall, when we use to accuracy model. So here also we can say the model is producing 100% performance, but this model is not that much efficient. Are you getting my point? That we should focus on that particular parameter which is important. Otherwise, we will say that our model is performing 100%, but in actual it is only 50% performing. So here, in the third situation, in recall. Recall is using true positive divided by true positive plus false positive. False negative. True positive divided by true positive plus false negative. It is considering the parameter false negative. It is not considering the parameter false positive. So in some situation, this parameter may also not performing well. So my focus is only on that. Whenever we develop a classification model, we should identify all the concept, all the values of input data, and according to that, we will apply the quality measures. We cannot blindly apply the accuracy model, or we cannot apply blindly on precision or recall, because this may not give only correct output. In terms of parameter, in terms of value, they may provide the 100% performance, but in actual, that performance is not effective for our satisfaction. Okay, so here this is also a value. F1 score is a combination of precision and recall. So we can use this formula. So based on these 4 parameters which are widely used in testing of classification model, we should use the F1 score. Because in precision, when precision is low, recall is low, then F1 score is also low. When we have precision low and recall high, then F1 score is also low. When we have precision high and recall low, then our F1 score is also low. And in last situation, whenever we have our precision is high and recall is also high, then our F1 score is high. So in this situation, we can say the accuracy is less important parameter because it may give 98% accuracy, but in real our system is not working. इसके और भी एग्जांपल है. For example, our term insurance policy. Why we are adopting a term insurance policy? For a worst situation when something mishappening. But at that time they will not provide claim to us. Then our policy is what waste. Same situation for any kind of medical insurance or any kind of fire alarm. In almost every building there are some fire system, but sometimes they are expired. And when there is a fire in the building, they are not valid. So what is the use of that kind of parameter? So accuracy is considered less important parameter, but it is widely used in our research. So we should focus that when we used to apply the accuracy parameter. Similarly for precision and recall and efforts. So these are the popular quality measure for the classification model, and these are widely used also. So now I would like to focus on some kind of ethical concern related to AI model, because almost everyone is using AI model nowadays. Sometimes we are developing also, but at least we are using the AI model. So here, our AI model should be fairness and bias. What is the meaning? That our input data, on that basis we are trying to develop our model. That should be fair and without bias. This is important in hiding loan approval or law enforcement. Because when we have input data faulty or input data noisy, then our model will train accordingly. So on that basis, it will train incorrectly or wrongly. So when we will apply it on the real data, it will produce the incorrect result. So we should focus that whenever we are training our model, our data should be sufficiently accurate, or we should apply some pre-processing technique for removing the redundancy or noise from the data set. Similarly, AI model should be transparent and explainable. Because in some time we are taking or we are using the AI model, when we provide some data set, it will produce some kind of result. So this concept is known as black box. That we don't know why it is providing this result. If our model is correct, then it may provide correct result, but we don't know whether it is a correct decision or not. So in that situation, our model should be transparent or explainable. That whatever decision it is providing, it should be transparent that why it is taking this kind of decision, or it should be explainable. Explainable AI is nowadays very trend, because we should have the AI model that should be explainable. Similarly for privacy and data protection and privacy is very common concern nowadays. So data misuse, unauthorized access, or data breaches. So whenever we develop a model, we should use some kind of ethical concern that will reduce this kind of problem. Accountability and responsibility. This is very important concern. That if we have AI model, then there are three persons who will be the responsible for any kind of fault. First, the developer. Can we say that developer is the responsible person for any kind of mistake in the AI model? Or we can say the organization who is applying, who is using that particular AI model, or third one, the user. Who will be the more responsible for any kind of fault in the AI model? So for this, there should be such a rule that who will be considered as more responsible, either developer, organization, or user. Because user is ultimately using the machine, but we can say he or she may not aware fully about the system. But organization should know because the organization has some kind of team that can be verified. And at developer level, if developer is not fully aware, then he or she can learn something about that, so that we can identify that whatever is the problem, it will be resolved in the earliest. Okay, safety and reliability. If we are developing a model, then we should concern about the safety. Nowadays, automatic vehicles are very popular in trend, like Tesla. If in Tesla there is some kind of problem, then who will be responsible? And so our AI model should be something like that will be less harmful or no harm full for the human being. Basically, our first concern is always about the AI system is that we should develop a model that will be beneficial for human being. That should not provide any kind of harms for human being. So this should be our primary concern whenever we develop AI. Or it can also provide some financial loss. Now, human control and autonomy. This is also a very important ethical concern that AI should support human decision making, not replace it entirely. If it will replace human entirely, then we can say AI machine is not in our control. So the ultimate decision or final decision should be in our hand. That machine is doing, then ultimately at last it will ask to us that this is correct or not. We should fire it or not. So the last decision should be based on human development. This application is also very important for military and medical applications because in military, if machine will take wrong decision, then we can have a big loss. Or in medical situation, it is also very important. Job displacement. This is also a very big concern that if we will apply artificial intelligence in everywhere, then what will be the situation of human being? Human being will be jobless. So for this, we should reskill or upskill the human being so that the gap between machine and human should be minimized. This is very necessary. So the government of India is also promoting some kind of reskilling or upskilling program and many kind of workshop and conference so that human being should be upskill or reskill according to the current situation or current market. Security and misuse. This is obvious that artificial intelligence can provide harm according to the cyber attack or other things. Then social and cultural impact. Yes. Ethical governance and regulation. So, for this type of ethical concern, the government should be use some kind of policies that should be transparency, fairness, beneficence, and non-beneficence. So, ultimately, we can say the responsibility of government is more for development of artificial intelligence system because government is ultimately the taking the final decision. If developer is developing, organization is using, and user is using, but all should be in under surveillance of the government. So government should develop some kind of rule for the use and development of the artificial concept. So here, my conclusion is that whenever we develop our artificial intelligence machine or model, then we should focus on something that our machine should be helpful or beneficial for the human being. It may not provide any kind of harm. So this is my final summation that our machine should be trusted, fairness, and safety, and responsible AI development must balance technology progress with human values and societal value. That our machine should not be harmful for human being. The main purpose of AI is to provide benefit for the society. Okay, so that's all from my side. If you have any questions, then you can ask. My my main motive of this talk is to aware about the classification model and accuracy model, because those accuracy model we are using in our research and the thesis or PhD thesis, and that or those quality measure are uh, many times not effective according to our data set. But these are providing 98% accuracy or 100% accuracy. So we should avoid this type of quality measure, or if we are using, then we should use correct input data so that it will provide the correct output. Okay. So thank you. If you have any questions, then you can ask.
Thank you, sir, for such an enriching session. Apart from delineating the basic concepts of artificial intelligence, how beautifully you gave us your insights on ethical consideration of AI. Thank you. All of you are requested to remain be seated as we are waiting for our second guest speaker. Students are requested not to leave the auditorium as we are waiting for our second guest speaker. Please be seated.
शायद सनन वो स्ट्रीमलाइन होना नहीं था तो वैसे मैंने बोल दिया था
सर कौन सा चैनल कौन सा है?
एबीएस के नाम से आ रहा है, मैं चैनल एंड ना हो जाए स्ट्रीम।
दूसरे टैब पे चेक कीजिए, लाइव चल रहा है ना, हटेगा नहीं।
एक काम करो, मैं आपको लिंक भेज दूँ, लिंक लो, लिंक ले लो, लिंक कॉपी नहीं कर लो, लिंक ये लिंक HTTPS वाला नीचे वाला। भाई हिलावत इसको बढ़िया लाइव चल रहा है सही है वेबकैम से चल रहा है इसमें रुकती रिकॉर्डिंग नहीं इसमें ना इसमें क्लिप तो कट जाएंगे वैसे
क्या
चले
कहाँ से लाइव आता है सारा जगह खोल के
यूट्यूब पे उत्तरांचल के चैनल पे आता है
Students, I request you to please do not leave the auditorium.
अभी पता है कि मुझे छोड़ दे दो वो ज़्यादा भाई बहुत कॉमेडी है अगर तुम सोच सकते हो I used to like what? Best comedy. भाई उसके बाद 3 बार क्यों कर दिया? फिर मैं कह रहा हूँ वाईफाई चल रहा है।
वाईफाई चल रहा, पासवर्ड बदल दिया पर इसका
क्या पासवर्ड है?
पता नहीं बता रहा।
आप भी तो वाईफाई यूज कर रहे हो, करवा दो थोड़ा सा, हॉटस्पॉट ही दे दो। हो रही है देख लो, दे दो। ठीक है, किस नाम से?
रेडमी नोट 9 12/12/4
हाँ, रेडमी नोट 9 प्रो। पासवर्ड देगा
12/12/4
12/12/4 नहीं सुना नहीं मैंने।
12/12/12 4 टाइम 12।
अरे ये तो खतरनाक पासवर्ड है। पता नहीं क्यों नो इंटरनेट एक्सेस दिखा रहा है, तो कनेक्ट हो
वैसे तो चला हुआ है,
चल रहा है आपका।
नहीं स्लो चल रहा है, स्पीड कम कर रखी है, स्पीड कम कर रखी है सर ने उसकी।
अच्छा, पहले तो सही चल रहा था।
इसके लिए
कर लो, बार बंद कर लो, नहीं चल रहा, काम का बैटरी खाए।
We take the whole possible linear combination of 0 and 1 and predict the possibilities. Instead of electrons, which is the main element to convey the information in electronic circuitry in classical mechanics, here we can use any kind of the entity which is relevant to us. It may be the spin of the electron associated with the atom, it may be the charge of the electron, it may be the photon or the spin of the photon. All these are subatomic system electron, proton, neutron, photon, phonons, etc. We can use either of the entity, quantum entity. Any intrinsic property can be utilized in the form of, instead of 0 and 1, we use two terms of 0 and 1, and then we manipulate and give the desired result. Let me explain. Suppose there is an atom, and we all know that an atom may have two kinds of spin up and spin down. We can call spin up cat 1 and spin down cat 0. Cat 1 and cat 0, these are representation of qubits, as we do in classical mechanics. Now the question is that how we can manipulate the spin to process the data. This is the fundamental question. How an intrinsic property can be utilized to process the data. So the main problem we are facing right now is the implementation of these bits in realities. IBM, Google, all these leading companies are taking part in development of the quantum computer. IBM has developed more or less quantum computer. In quantum computer, 90% you will see the circuit which is based on the superconducting material. Because when we process the data in supercomputer, we don't need to take care about the temperature. But in case of quantum computer, we have to be adhere with the very lowest temperature, up to minus 272 degrees centigrade. So all these quantum circuits are operated at absolute zero, near to absolute zero. Have you ever looked? I hope you have seen the figure or picture or pictorial representation of a quantum computer. Certain type of the coils which are used to sustain a temperature near to the absolute zero. Now the question is that how any intrinsic property can be utilized. Suppose we have an atom, and the central part of atom is nucleus containing proton and neutron, and the electrons are revolving on the nucleus. So this is the simplest picture of the atom. In this atom, the electron may be in up spin or maybe in down spin, plus half or minus half. These two representations of spin can be represented in terms of cat vector 0, cat vector 1, 0 and 1. These are two qubits. So we are representing two different intrinsic property in terms of two qubits, cat 0 and cat 1. Now the question is how these two qubits can be processed and manipulated. There is a very fundamental rule of quantum mechanics. Suppose a system has two states. A system can be either in state 0 or in state 1. When we say state 0, it means we cannot predict whether system exists or not. We are not certain whether system has its physical presence or not. This is cat 0. Cat 0 implies we are unable to predict any kind of the possibility. Whereas cat 1 represents that we are certain that system exists or system can predict any properties. So cat 0 means we are unable to recognize any property. Cat 1 means we are 100% sure we can recognize the property. Cat 0 means we are unable to detect the spin. Cat 1 means we know whether it is in spin 1 or spin 2. So these are two possibilities, cat 0 and cat 1. What we do? Then we take the linear combination of any true intrinsic property. These true intrinsic property may be the spin, angular momentum, or it may be the magnetic moment, it may be the magnetic spin, etc. It may be anything else, but these should be associated with the any kind of the subatomic system. So we have taken spin up and spin down, these two intrinsic properties as cat 0 and cat 1. Then we multiply these two values with two arbitrary coefficient alpha 1 and alpha 2. When we multiply a coefficient with a variable, this is called linear combination. So when we multiply a value of alpha 1, which is a coefficient, nothing else, it may have any value, and alpha 2, it may have any value, but this is a coefficient. When we take the linear combination of these two states in terms of the two coefficients, a new function arises, the psi function. What is this function? This is the wave function. And what is the meaning of this wave function? This wave function will tell what is the possibilities of having the system between these two states 0 and 1. That is all possibilities between 0 and 1. It does not tell you whether the system is in state 0 or in state 1. Rather, it is stating that the system may lie elsewhere between 0 and 1. So this prediction have a lot of values. It will not predict a single value. It will predict a different value. Although the square and sum of both the value will give the 100% possibilities. The choice of taking the coefficient depends on if we take the sum of the square of the absolute value, it should be 1. 1 means 100% possibility. So how we choose the coefficient? The choice of choosing the coefficient depends on the possibility prediction. If the possibility is 1, you may choose the coefficient, otherwise no. So we choose two coefficients and multiply with the two states. Two states means two intrinsic property. And these two intrinsic property, when we say 0, it does not mean it is a 0, numerical 0. No, it is a mathematical function. 0 is not 0. It is a mathematical function which is representing spin up or spin down. Similarly, 1 is a mathematical function which is representing spin up or down. So when these two quantum states are multiplied by two coefficients, then we get a new wave function. And this wave function is also known as eigenfunction. And this function can predict all the possibilities that lie between 0 and 1. So this is the fundamental aspect of the quantum computer. We take any two properties of any subatomic system, we take the linear combination of them, a new function arises, and this wave function gives us different values. So these values predict all possibilities, all possible ways, all possible outcomes which lies between 0 and 1. So unlike 0 and 1, here is a linear combination of 0 and 1. So this is referred as qubit. So what is a qubit? Qubit is basically a superposition of both the states. Both the states means two intrinsic properties. So this is the representation of a data in quantum computer. So let me make you aware in a nutshell. We take any two properties of any subatomic system. These two intrinsic properties are multiplied by two coefficients. When these coefficients are multiplied and add suitably, this is called superposition. And the resultant function is referred as qubit. So this is the fundamental data of quantum computer. Similarly, apart from 0 and 1, we can take another properties, but these properties should be inherent and intrinsic. We cannot arbitrarily choose any properties. Like spin, we are now focusing on the photons. The researchers, the scientists are more focusing on the photon because there is a restriction of the movement of electron in circuit. We all are aware. When electron moves in a circuit, it produces a resistance. Because of this obstacle, we are unable to compute as fast as we expect. So the movement of electron is a restriction for us in computation process. We want to overcome from this. So instead of using photon, instead of using electron, we are using photons. Right now, IBM has developed a fully functional quantum computer utilizing photons. Although the idea was originated from the spin state of the atom, but now photon is being utilized as a bit, as a qubit. So like electron, photon is also a subatomic system, but we have to face the restriction. So in order to overcome from all this kind of the restriction, we use photon because the maximum possible speed which we can expect can be realized by photon. So no particle can travel faster than the speed of photon. So instead of electronic circuitry containing metals, we use fiber optics. We use optical fibers which can convey the light, and these lights and these photons are converted into, it does not imply that in quantum computer electronic circuitry is not used. No. In quantum computer electronic circuitry is used, but in 98% photonic circuitry is used, where we use optical fibers to carry the optical signals. These optical signals are converted into electrical signals and manipulated. Apart from that, other electronic circuitry is based on the superconducting materials. Because if we use usual semiconductors, there is a fluctuation, and this fluctuation can distort the state of the system. We need absolute environment for the flow of photons. The photons should not be obstructed by any kind of disturbance. So we usually settle the system at absolute temperature around -272 degrees centigrade. So the huge system which we see in any quantum computer is made up of a combination of thermodynamics, physics, chemistry, electrical engineering, electronics, etc. So quantum computer is not a sole discipline, rather it is a combination of different disciplines. It involves physics, chemistry, mathematics, electrical, etc., etc. In coming days, in coming decades, or in coming years, you will see that your laptops, your cell phone will be connected with cloud, and the cloud will be processed by the quantum computers. So you will be carrying a supercomputer in your pocket. So these days are not far away. Now let us consider a 3-bit qubit register. What is a register? Register is another important element of the quantum computer, like wave function or eigenfunction. So we use various kind of the register in quantum computer. So what is qubit register in a quantum computer? It is nothing but it is a equal weighted superposition of all possible states, just like 0 and 1. Other states may also be possible. So eventually, a data in quantum computer is represented by the linear combination of all possibilities. In general, an n-cubed register can represent the number 0 through 2 raised to power n minus 1. What does it mean? What does it mean? Classical computers have limitations, and these limitations come because of the electrical resistance offered by the circuitry. Similarly, in quantum computers, there is a resistance which we cannot ignore. So these resistance have obstacle in quantum computing as well, but it doesn't mean there is a huge gap in classical and quantum computing. Quantum computing processes are very fast. Suppose we have two different states, 0 and 1, and we have a function psi which represents in qubit. Now let me make you clear how the role of register takes place and how the data is retrieval. Suppose we have two different states, 0 and 1, and we take the linear combination of these two states and form a new function, eigenfunction or wave function. This wave function predicts all possibilities. How does a quantum computer predict all possibilities? There is a rule which is referred as quantum entanglement. This rule enables these two qubits to correlate with each other and to give the desired predictive results. What is quantum entanglement? Suppose there are two subatomic systems, two subatomic properties. So at subatomic level, all subatomic systems are correlated with each other. Nothing is in isolation. The effect of one will affect on another. If we disturb one system, it will influence the other system. So if we have two qubits, 0 and 1, if we disturb one, it will disturb 0, and vice versa. So when the two subatomic systems are correlated with each other, and if we perturb one system, it creates a fluctuation on other system, and it's vice versa. This is referred as quantum entanglement. So there is a time delay. There is a very small time delay in the communication. Let me make it clear. Suppose we have two photons, and these two photons are placed at 1 meter apart. If we change the spin of one photon, immediately the spin of other photon will change automatically. This photon will communicate with other photon, and if you change the spin of one photon, the other photon accept the information. These two photons communicate to each other as we do communicate. So if the change in one property will influence the other property. So these two quantities are correlated. This is how quantum or subatomic system participate in nature. So quantum entanglement is nothing. It is a communication in subatomic system. But during this communication, there is a delay of time. This delay in time is the resistor or obstruction. We need different kind of the obstruction or resistors to control the communication system. So these are called qubit resistors. So qubit resistors are basically the resistance in quantum entanglement. And this quantum entanglement has a we have recently realized the reality of the quantum entanglement during the detection of the gravitational wave that was predicted by the Einstein quite earlier. Now we are in a situation whether the quantum entanglement is a reality or it is a hype. Of course, it is a reality, and this quantum entanglement is another element of the quantum computing. Number one is qubit, number two is quantum entanglement, number three is resistor. So these are three essential elements of quantum computer. Qubits, which is a representation of the superposition of two states. Quantum entanglement, a internal correlation or connection or interconnection between two properties, and the delay meanwhile communicating the quantum resistor. So these are two fundamental elements of quantum computer. We have read that in classical computer we use different kind of the semiconducting gate, AND gate, OR gate, etc. These quantum gates are used for logical operations, addition, subtraction, differentiation, integration, etc. But in quantum computers, we don't use gates, this kind of the gates. Instead of these gates, these semiconducting logical gates, we also use gates, but these gates are not physical. They are virtual. They are virtual in the sense we cannot see them. Although we implement logical gates to process data, but we cannot see the gate. These gates are nothing, but these are matrices. You have read matrices, different kind of the matrices play the role of these gates. So this is the simple AND gate, and there is an input and there is an output, and in these three cases information is being transferred. In these cases the input and output process is given. If A and B are 0, the output is 0. If either one is 1, this is still 0. If both is at high level, this is the output. So this is the simple AND gate, and its logic can be understood with the help of this truth table. This is the case of classical computer, but in quantum computer we don't use these kind of the gates. We use matrices instead of logical gates. This is another example. This is the first example of gate in case of quantum computer. We don't use semiconducting logical gates, we use matrices. This is an example of Hadamard quantum gates. This is the one of the simplest gate, which is known as the square root of known gate. It is the anonymous of NOT gate. This is NOT gate. We can replace this NOT gate with Hadamard gate. You can see that there is a state 0 at input. There is a Hadamard gate in between. We have put two Hadamard gate, this state 0 and state 1, and in between we have taken the superposition of these two states. So how does this gate work? We see that we have a state 0, which is a property of any subatomic system. We have a state 1, which is another property of the subatomic system, and we have put two Hadamard gates. What are these gates? These are matrices, usually poly matrices, in the form of 0 and 1. So instead of using the physical gates, we use matrices to manipulate the desired output. So we have different kind of the gates, and these gates help us to process the input data and to give the logical data in the form of output. So we can manipulate different logical system with the help of matrices, simply matrices. Matrices means arrangement of numbers. So we can rescale the machinery from a very last to very minimum level. Quantum computer is not a very huge machine. It is a very small machine, but it looks very huge. It looks very huge because we have to maintain a temperature of -272 degrees centigrade. This is the only answer behind it. Otherwise, quantum computer is a very small machine, and that machine is capable to perform the task very fast, beyond our expectations. Recently, few papers has come, and these papers have predicted that if 1,000 supercomputers are accumulated at one place and were given a task to compute a given task, if all 1,000 computers take 1,000 years, a quantum computer take almost 1 femtosecond. So you can see the processing speed or the cost of computation between the classical computer and the quantum computer. So the quantum computers are more smallest than the classical computers. Although to sustain a temperature near to absolute, we need huge machinery. So there are few elements when we talk about the computers, especially quantum computer. Number one is qubit, number two is register, number three is quantum entanglement, and number four is gate. So all these four elements together are used to manipulate the data. Apart from head-mart gate, other logical gates may be manipulated. So we have different kind of the gates, and these gates control the input signal, like in classical computer. But in all kind of the gates, we do not use any kind of the semiconducting physical entity, rather we use matrices. So there are varieties of the quantum gates, and the race is behind the development of these gates. More faster is the processing of a gate, more faster we can achieve the desired calculation. So there is a race in development of these gates. So the time now is not about the facilities. The time is about to introduce new kind of the matrices, new kind of the algorithm. Better is the algorithm, better will be the speed. So the whole world is in the race of developing these matrices. Various kind of the algorithms are being designed, are being taken care, so that we can develop different kind of the matrices. These matrices are used to develop the logical gates, and these gates can be used to manipulate the data. So the whole world is in the race of developing quantum computer. So here the important point is development of algorithm, development of new kind of the matrices, not the development of semiconducting metals, electricity. No, this is not an issue at all. Because when we use quantum computer, it does not work simply like classical computer. It works on the intrinsic property of the subatomic system, and these properties of the subatomic system can be manipulated, can be encrypted by a number of ways, and only the users know how he or she has encrypted it. We cannot detect the encryption behind the quantum computer, because the input quantity 0 and 1 can be spin, can be magnetic moment, can be anything else. So the prediction is not possible at all. So these are the example of different kind of the operations which can be accomplished by the different gates. You will learn all them in your curriculum or in your research work. Yes. This is another skeleton element of the quantum computer, the SOR algorithm. This is very famous algorithm which is used in quantum computing. Algorithm, as you know, is a well-defined mathematical procedure in which we feed certain input and get the desired output. So in a similar way, SOR, the name of the scientist, he developed an algorithm which is used in quantum computer. The computer utilizes this algorithm and computes. The peoples around the world are in the line of developing the algorithm which is similar or more advanced than this algorithm. But so far, no one has developed any kind of the algorithm which is more important than this algorithm. So this is the most desirable, most reliable algorithm. But all around the globe, there is a race. So what is SOL algorithm? This SOL algorithm, in principle, makes a computer to factorize a number in a very small element. We have a string of number, and we want to make the prediction of that number. How we will predict it? So what we do? We make the smallest factor of that number using prime numbers. Creating a prime number is not an easy task. SOR algorithm, to a certain extent, makes it feasible. So behind the SOR algorithm, the purpose is to develop different factors of a number. So this is the backbone of SOR algorithm. This algorithm depends on arithmetic operations, parallel operations, and the transformation of these numbers, in which Fourier transform is one of the most important parameters. So if I say, what is SOR algorithm? SOR algorithm factorize a big number in small units. These small units are prime numbers, and we process these prime numbers. We take arithmetical operations, parallel operations, and we take the Fourier transform of these numbers. These prime numbers eventually represents a function, a mathematical function. And these functions are in the form of waves, a complex waves. When we say zero, zero does not mean it is zero. Zero means it is a mathematical function, and that mathematical function defines a wave. So what actually happens in a quantum computer? Unlike electron, we have an intrinsic property of any subatomic particle. That property is picturized in the form of a wave, and that wave is represented by a wave function. And this wave function is manipulated to give the desired result. So this is a SOR algorithm which is based on factorizing a number. And in this SOR algorithm, Fourier transformation is another important transformation which is being used and to manipulate the data. Why we use Fourier transform? We usually use arithmetical operations in our daily life, parallel operations in our daily life. But what is the utilization of Fourier transformation in quantum computer? Fourier transformation basically make a complex system into a simple system. A wave is a complex system. It may be periodic, it may be non-periodic. Fourier transformation makes that complex wave into simple wave, sine wave and cosine wave. So this is the purpose of Fourier transformation. To make easy, to fabricate an easy way of realizing a wave. Let's discuss SOR algorithm in reality. Suppose we have an odd integer n. To factor an odd integer n, let's choose a number 15. So, if this is an integer, then how we can make other factors from this integer, which are itself integer, not a fraction. So we have different kind of the factorial technique. I will not go in this in very detail. This is not at all relevant for you. I am just here to give the idea about the basic quantum computer. Basic quantum computer. Yes. So I will not go in detail of this SOR algorithm. How does it work? Because it requires complex algebra, real analysis, Fourier transformation. But the task is not as easy as you are thinking. Even to develop a simple prime number is not an easy task. We cannot develop numerous prime number. After a certain extent, we fail to create new prime numbers. So SOR algorithm is basically factorizing a big number in the form of prime numbers. And these prime numbers are not number. These are basically complex system, complex waves, which are represented by prime number. So this is one of the basic algorithm which we deploy in quantum computing. So the four elements are qubits, register, quantum entanglement, and the gate. These four elements make a computer in quantum computer. So the race is behind the quantum computer is because we can process the data too much fast, and scalability is based on the designing of new kind of the matrices, new kind of the algorithm, similar to the SOR algorithm. People are in the race of developing the algorithms, but we are still far behind. Although we are expecting that within 2 or 3 years, the people will be able to realize the quantum computer in reality. Right now, this is in infancy state. Although IBM has claimed that they have developed quantum computer, but still this picture is far behind. So if you have any query, I have tried, because the topic is very new even for me. Even this is very new for all those who are in the quantum field, quantum computation, quantum computing. This is in infancy state. We are learning. We are struggling to know the complexity behind the quantum computer. This is not as easy as you are thinking. To develop a new algorithm is not an easy task. To factorize a number is not an easy task. Even to sustain a absolute temperature is not an easy task. Quantum computers in future will not be utilized for you and us. They will be utilized for commercial or advanced purpose, especially in protein folding, railways, defense system. We will not be able to handle them. They will be utilized by big companies, big corporates. But eventually, they will impact on using the way we use the classical computers. So if you have any query, you are welcome. You may ask me anything else. So this was a little about the quantum computer. Any query? Any query? So you may ask any query after this session. There is a paper. Those who are in final year, there is a paper of quantum computing. They will learn a little about this quantum computing, Shor algorithm, entropy, quantum mechanics. So you need to understand each and everything if you want to go in quantum computing. And if you are not interested in quantum computing, you will be compelled to introduce yourself in quantum computing. This is not in your hand. You have to have in your quantum computing. So to understand the quantum computing, you need to understand physics, chemistry, electrical, mathematics, everything. You can't isolate yourself to learn. I will not read it, I will not study it. You have to have this. So this is a little about the quantum computing. Thank you very much.
Thank you, sir, for such a knowledgeable and enriching session. Now, all the participants are requested to make a move towards the yoga hall for lunch. Thank you. Students are requested to go to